Now, for a military guy with need-to-know clearance, this kind of surprises me that questionable education would put this out. Talking about the Sea Sparrow Block 1 missile. It is a variation of what was originally an air-to-air missile. But the interesting thing right here is it's a surface-to-air and surface-to-surface radar-guided missile. Now, they're making a lot of hay here about the fact that the radar that guides the missile has to have line of sight to the target, and that the range is greater than 35 miles. Please explain how you have a line of sight 35 miles away on a spinning ball by showing how a 2-degree radio frequency pencil beam can penetrate 463 feet of target hidden height through a wall of water 26 miles in length. Very interesting. So, his entire argument is that from the launcher on the ship, in order to have line of sight, it would have to go through the Earth and sea on a curved Earth. But even taking a cursory look at the actual characteristics of the Sea Sparrow tell you something very interesting. And that's right here. You see where it says guidance system? Mid-course, data link, semi-active radar homing. Now, the semi-active radar homing means that when the missile is close enough to the target to paint it with radar, it will start painting it with radar and bring it in the final few miles. However, what does this mid-course data uplink mean? Command guidance is a type of missile guidance in which a ground station or aircraft relays signals to a guided missile via radio control or through a wire connecting the missile to the launcher and tell the missile where to steer in order to intercept the target. Now, the key thing that they're missing is they want to assume that all of these missiles at maximum range are somehow being guided from the ship, neglecting the fact that you have spotter aircraft overhead that paint the target for the missile to home in on and tell the missile where to go until it's close enough to hit it with its own radar.
Apparently, this United States Navy fact sheet on the ESSM is the holy grail reality deniers are using to claim the Earth is flat. Let's take a closer look at this document to determine where the flat Earth cherries are picked. The first cherry lies here. ESSM is a medium-range semi-active homing missile that makes flight corrections via radar and mid-course data uplinks. According to the Fundamentals of Naval Weapons Systems publication, in semi-active homing the target is illuminated by a tracking radar at the launching site or other control point. Reality deniers conveniently ignore the other control point part. Let's play along. For the sake of this discussion, we are going to assume the launching site is the only method of guidance. If we don't, the reality denier claim is already debunked by the fact the ESSM can be guided by other radar sources. Stick around for more on this at the end of the video. Here is the second cherry. The primary function is both surface-to-air and surface-to-surface. The third cherry, or lack thereof, is that the range of the weapon is classified. Reality deniers love to play in the gray area. A Google search finds open source information claiming the maximum range of the ESSM is 50 kilometers, or approximately 31 miles. The problem is, there are no details on whether this maximum range is achieved when operating surface-to-air or surface-to-surface. Thus, we enter the gray area. At this point, the reality denier will assert the following. The ESSM can be used against surface targets, the missile has to be guided by the firing vessel, and the missile has a maximum range of 31 miles. This is impossible under the heliocentric model since the target would be hidden by the curvature of the Earth at 3.1 miles. Checkmate, the Earth is flat and the United States Navy is hiding it. We'll first address the ESSM's maximum range versus its effective range. The AIM-7 Sparrow missile was originally designed as an air-to-air missile which was utilized by aircraft. The AIM-7 was modified to the RIM-7 Sea Sparrow to allow operations aboard naval vessels against surface targets, which resulted in a noticeable degradation of the weapon's capabilities. One of the biggest effects of these modifications was a severe reduction in maximum range. Here is an excerpt from a 2004 Naval Institute guide that discusses the limitations of the Sea Sparrow missile. At low altitudes it does not produce enough power to overcome drag and dramatically decreases range. Some estimates indicate that the Sea Sparrow may be effective only to 10 kilometers, about 1/4 of the range of the air-launched Sparrow. Maximum range can only be achieved during the best-case scenario for the weapon, and the best case for the ESSM is a surface-to-air engagement. Since it was estimated that the original Sea Sparrow would only have an approximate 25% effective range against surface targets, one can conclude that the ESSM would have a 7.75-mile range in surface engagements. I will concede that the ESSM has received multiple upgrades to overcome some of these deficiencies, but the ESSM is still primarily a surface-to-air missile. To believe these upgrades alone could double the weapon's estimated surface-to-surface performance would be highly dubious, but for the sake of this discussion, I'd be willing to concede to doubling the estimate to an effective surface-to-surface range of up to 15.5 miles. Why does the Navy go to the trouble of engineering these tall, elaborate masts? It's almost as if they're trying to see over something. I wonder what that might be. Let's take a closer look at 3 ships that deploy the ESSM on board. The Arleigh Burke-class destroyer, the Ticonderoga-class cruiser, and the Oliver Hazard Perry-class frigate. The final variable we need to consider is the target. A go-fast boat at best can achieve 60 miles per hour on choppy waters, so even at 3.1 miles it would take over 3 minutes to reach its target. The most challenging threat an ESSM would face at sea would be a fast-moving, low-flying cruise missile, which at these altitudes can be considered a ground-to-ground engagement. We now have the data required to input the numbers into Walter Bisland's advanced Earth curve calculator to determine at what distance this worst-case scenario cruise missile at 50 feet above the water would be identified on radar. I'm going to set the refraction to 0 and require the target to be 10 feet higher than the radar horizon to account for potential clutter and to allow a gap between the missile and the Earth for the benefit of the reality denier's claim. Under these conditions, an Arleigh Burke-class destroyer would first identify our worst-case scenario cruise missile at 16.8 miles. Under these conditions, a Ticonderoga-class cruiser would first identify our worst-case scenario cruise missile at 17.28 miles. Under these conditions, an Oliver Hazard Perry-class frigate would first identify our worst-case scenario cruise missile at an impressive 20.28 miles thanks to the new location of the Thales radar unit on the upgraded version of the Perry-class frigate. As you can see, even the 16.8-mile radar range of the Burke-class destroyer is 1.3 miles farther than the more than generously calculated 15.5-mile range of an ESSM operating in a surface-to-surface capacity. Interestingly, the repositioned radar on the Perry-class frigate has added 3.5 miles to its range when compared to the Burke-class destroyer. Even an outrageously small 5-foot ship moving at an outlandish speed of 100 miles per hour would be detected by the radar on the Burke at 8.9758 miles. Some elementary school math determines it would take this ship another 5 minutes and 23 seconds to reach the destroyer. Let's see how much ordnance a United States Navy destroyer can put downrange in about 10 seconds. Do you think they really need more than 5 minutes?
So once again, this isn't so much an argument for the flat Earth as it is a basic misunderstanding of how radar guidance works and how line of sight works. But is that really the case? This is science denial, and one of the tenets of science denial is that you simply look for ways to deny science. This isn't about inquiry or fact-finding or respective evidence. Does Quantum Eraser understand how line of sight radar works? That's debatable. If somebody explained it to him in detail, would he listen? Especially if it violated his flat Earth narrative? No, I don't think so. Do you believe that if somebody sat him down and carefully explained it to him, that he would accept that explanation if it violated his narrative? I don't think so. So, Next time, we're going to have a look at another, shall we say, misunderstanding that he has, and that is the Coriolis Effect. But please take a moment and subscribe to this new channel. I think that you're going to see some very interesting original material here. Thank you again for stopping by, and we'll see you soon.